Hello, everyone. My name is Sofia Albrecht, and I will present you my master thesis about habitat use of Minke whales in Skjálfandi Bay, North Iceland. Minke whales, the species name is the common minke whale, Balaenoptera acutorostrata, and they are around 8 meters in length and 9 tons in weight in adult individuum, which makes them the smallest of the rorquals and the second smallest of all baleen whales. It is actually a species complex with the common minke, the one I'm working with, that is mostly distributed northern, but also global. You can, yeah, here is the map. And then on the other side, there's the Antarctic minke whale, which is way rarer. It is generally a very mysterious species. Little is known, for example, migratory routes or where they reproduce and social behaviors. They were long thought to be solitary animals, but now we get some doubts about this. We actually don't really know. They're very fast swimmers and hard to study due to their shy behavior. This might be because they were a long target species for commercial whaling and scientific whaling, which they are still in, for example, Iceland or Norway. In their ecology, they are filter feeders, so they feed on plankton and small schooling fish. They are internationally protected under the CITES Appendix 1 and 2, like other cetaceans, and their global state is least threatened. There are around 200,000 individuals to be estimated. But the state in the North Atlantic is a bit less clear because there had been some reports about sighting declines around Norway and Iceland. We don't really know. And then there had been reports of an increase around Svalbard. So we are not sure if there is actually a species distribution shift northern, as found for a lot of other species, or if it's the population varying a lot. The study area itself is Skjálfandi Bay. It's in the north of Iceland. It is an important summer feeding ground for various species like the humpback whale, the fin whale, the blue whale, and the minke whale. And it inhabits smaller species year-round, like the harbor porpoise, the white-beaked dolphin, or minke whales also. It is the whale-watching capital of Iceland, and it has an established monitoring project for cetaceans from the Húsavík Whale Museum and the Húsavík Research Center. Then it is very interesting to talk a bit about the debate whale watching versus whaling. Whale watching is actually very recent. In Iceland, it just started in 1994. And for example, Eidur Gudnason in 1985 said in a public meeting, whale watching in Iceland, that's the most stupid thing I've ever heard of. It is an insult to all Icelanders. But then if we check recent statistics from the tourist office, we see that it has actually such a high value nowadays. In 2018, there were 350,000 visitors coming for whale watching, and it is increasing over the years. In comparison, therefore, we have the quotas of minke whaling and fin whaling, commercial whaling from Iceland, giving every year various hundreds, around 200 something. But it is just one company operating from the south, taking a few individuals more for a traditional value or personal, like they sell it, but it's not their main business. If it's just a few individuals taken, like 17 or 6, they operate just in the south of Iceland, but if it's various dozens, like 46, it is around the whole coast. And then 2009, Húsavík and Reykjavik Bay was declared for whaling-free areas due to pressures of the whale-watching industry. So I formulated my research questions, which were, how did the minke whale population develop in the last years? Are there any trends? And second, how do they use their habitat in Skjálfandi Bay? No one ever looked on mapping or distribution in this area before, besides me now in the north on minke whales. So I wanted to check, are there any spatiotemporal variations? Are there distributions after time factors like year, months, or daytime? And are these differences in distribution because of prey distributions? And then in addition, I wanted to check individual movement patterns. Are the individuals site fidel? Are they attached to one site? So I used as a method the continuous sighting and photo ID catalog that was maintained by the research center, where volunteers set up the data on whale-watching vessels. This is one of the vessels used. They are between 15 to 25 meters long, and the observers would stand on top of the wheelhouse to watch the whale. My tools for data analysis were RStudio and Excel for data handling, modeling, plotting, and calculating kernel densities. And I plotted in, I mapped in ArcMap. Then coming to the results, I first wanted to look on statistics of the company itself. There are mainly two companies operating in Husavik, North Sailing and Gentle Giants. This is a regression of the number of trips that the company made through the years, and it is significantly increasing. The second one is the number of trips with a researcher, with an observer, which is also significantly increasing through the years. In contrast, the number of minke-positive surveys, so the relative number of trips a minke whale was seen, is significantly decreasing through the years. Checking further, I wanted to look at the numbers, so at the sightings per unit effort, how many whales were seen per hour. And therefore, I performed a Poisson GLM with the factor year and month, standardized by hour. And I see there is per year, from 2005 until 2018, a lot of variation. There's no clear trend that we see, but we see there is a lot of variation. In the first years, it is quite low, but it might be because of the surge effort that was very small or smaller in the first years. So we are not sure if it is actually representative. And then it's hard to say there might be a decline here, but we have to be careful with this. Over the months, we have a typical seasonal pattern with an increase over spring, and then a high peak in summer, and then decrease in fall. Then I come to my mapping part. Oh, no, sorry. Then I come to my mapping part. First, I did a general map of all the sightings through all the years to get an impression. Where are the areas that are interesting? And it looks like it's mainly along the shores. It is the big area is always 95 kernel density estimator, then 50% and 25%. To check for temporal variations, I did a model, a linear mixed model, with the time factors, different years, season, month, daytime, and the interactions, setting individual as random factors, because I thought individual movement patterns do matter. And then I used longitude and latitude just as numbers, so I didn't take account of their coordination nature. Just assuming if the number changed, the location changed, which is kind of true, but therefore we have a very low R-square. However, if I check the next page, where is the model with the latitude, exactly the same. It is the same factors that are significant, so we believe it is true. I had significant factors, year, season, month, and daytime, and some interactions. And these get quite clearer if we look at the maps. I found interannual shifts from 2005 to 2009. The weights were more to the right side of the bay. Then from 2010 until 2012, they switched to both sides with the core areas. And then from 2013 onwards, the core areas were more at the left side of the bay. We don't really know why. We know that around 2010, the humpback whale abundance increased more. They were not there before, and then they came in higher numbers. This might have been a driver that the community changed, or different factors might have changed. Then I plotted the monthly kernels from April until November. And just to have a fast look, we see, OK, there is a dynamic. This dynamic gets clearer if we look at seasonal shifts. In spring, the minkes, or the core areas, are along the shore. Then they distribute wider over summer. And in fall, they are just in the middle of the bay. I wanted to look into prey distributions, which I did, and I did fishermen interviews. And they told me that capelin and cod is around the shore in February, and capelin is around the shore in February and May, and cod is there in March and April, exactly where our minkes were along the shore. Then I was mapping chlorophyll A to check for the plankton bloom, and it is again a very fitting pattern. In spring, there's barely plankton rising over summer, and then in fall, there's a bigger bloom. So I assume from this that this causes our distribution changes. So we also have a shift in prey. In spring, minke feeds on the fish, and then in summer on plankton. Summer and fall. I mapped daytime differences, and it's quite harder to see a pattern. Maybe they might be more split in the morning. I split it a day in equal parts to just have a look at them. Maybe they might be more split in the morning, but then they're again closer to the shore at the site. In the second part of my analysis, I used photo identification. I was able to identify 106 individuals in 258 GPS sightings, and 40 of those, so 38%, were captured more than once. 25 out of this 40, so 36%, were identified through various years. 32 out of this 40, so 80% of all individuals, were recaptured in different months. And 26 out of this 40, 65%, through various seasons. I was checking especially this because I knew there are seasonal and interannual differences, so I wanted to make sure for the further analysis that recaptures differed in these time factors. Then in the site fidelity analysis, I also just took recaptures that were more than 1 day apart to account that the individuals were not close because they were just close in time, but they were close because they're attached to the site. Therefore, I also checked the differences between recaptures plotted here. So just a histogram frequency with the time distance between recaptures. And we have a mean of 460 days and a median of 250 days, which is quite good, I guess, or good enough to go in my analysis. And then I followed an analysis that previously was done from Karen Lohne for checking for site fidelities on polar bears based on marked recapture positions in Svalbard. I was also in contact with her. And what I did, is that I calculated the distances between recaptures, like the geographical distances, and compared those to 999 permutations of those distances. And I resulted in a P of 0.001. The smallest distance, like the real distances, were smaller than all permutations, which is great. And thereof, I did the kernel functions. The solid line are the real distances. We see there are more short distances, and the dotted line are the random permutated distances, which have higher values in higher distances. Then I mapped the individuals just to have an impression how could it look like on the next slide also, on the next slide. But we have to say sample size is very low. So we get an impression, okay, there might be differences, some overlap, some do not, but it's hard to conclude anything out of those. And then coming back to my research questions, I checked how did the minke whale population develop in the last years. It's hard to say. What we can say is that there's a lot of variations. How did they use their habitat? I found interannual differences in distributions, interseasonal differences in distributions according to prey distribution, and differences in distribution depending on daytime. Moreover, I found small-scale site fidelity. This is absolutely amazing. No one found this out for minke whales yet. Nowhere, or not that we know of. There were some people that did mapping, but no one tested. So that's great. And implications for further research and conservation are, again, the population status. We have to check, especially in the North Atlantic, where we don't know or where we have to keep track of. And then there might be difficulties in area management. So we are dependent on prey distribution. This we know for sure. This was also found by a lot of other studies on minke whales. And we have small-scale site fidelity. This also applies especially, or for example, for the regulation in Husavik and Reykjavik Bay, where is a whaling-free area. But if whales are attached to one side, it doesn't apply to the whole population, but just to the few attached in the bay. And then it might be very interesting to check for group clustering in case there will be more data collected. Because there was a study from Dorsey, I just added it small, that found, but also just by mapping, that groups were allocated in adjoining ranges next to each other, also very site fidel. So therefore, first I